The fastest train in the world just left. It's still going to take 3 hours. Now imagine a pod, sealed in a vacuum tube. No friction, pure speed. Faster than a commercial aircraft. Los Angeles to San Francisco, 28 minutes. High-speed rail took a century to build. The Hyperloop could make it obsolete. The race to build it has already begun. Hit subscribe because the way humanity moves is about to change forever. For 2 centuries, rail has been the backbone of human transportation. Steam, diesel, electric. High-speed rail pushed that to its limit. The fastest lines in the world top out around 220 miles per hour. But even at those speeds, a journey from New York to Chicago still takes 18 hours by rail. The question physicists started asking was simple. What if you removed the air entirely? Air resistance is the single biggest enemy of speed at ground level. Eliminate it, and the physics change completely. In 2013, Elon Musk published a 57-page white paper. He called it the Hyperloop Alpha. He released it open source, free for anyone in the world to build upon. Within 2 years, private companies were already racing to turn the concept into reality. Virgin Hyperloop built a test track in the Nevada desert. Passengers rode it for the first time in 2020. That first ride hit 107 miles per hour, proof that human passengers could survive the system. Suddenly, governments were paying attention. Feasibility studies launched across Europe, the Middle East, and the United States. The UAE announced plans for a Dubai to Abu Dhabi Hyperloop link, a 12-minute journey replacing a 2-hour drive. Europe followed. Plans for Hyperloop corridors connecting Amsterdam, Brussels, and Paris began taking shape. But building a Hyperloop isn't just an engineering challenge. It's a systems challenge unlike anything ever attempted. Vacuum tubes, magnetic levitation, linear electric motors, every single component has to work in perfect coordination. The question was never whether the physics worked. The question was whether humanity could actually build it. To truly understand the Hyperloop, you first have to understand what makes conventional transport so slow: friction and air. At high speeds, air resistance grows exponentially. The faster you go, the harder the atmosphere pushes back against you. The Hyperloop solves this by depressurizing the entire tube to near vacuum conditions, roughly 1/1000th of normal atmospheric pressure. Inside that vacuum, aerodynamic drag virtually disappears. The pod is no longer fighting the atmosphere, it's gliding through nothing. But removing air is only half the equation. The pod also has to move without touching the track. That's where magnetic levitation comes in. Opposing magnetic fields generate a repulsion force powerful enough to suspend the entire pod mid-air. Zero contact, zero friction. Propulsion comes from linear induction motors built directly into the tube walls. Electromagnetic pulses push and pull the pod forward continuously. The result is a passenger experience far smoother than any commercial aircraft. No turbulence, no engine noise, no vibration, just smooth acceleration. Managing all of this requires an autonomous control system monitoring thousands of variables simultaneously: pressure, speed, power, and pod position. The tube itself must maintain near-perfect vacuum across dozens of miles. Even a small pressure breach would bring the entire system to a halt. The energy demands are significant, but proponents argue the system can be powered entirely by solar panels mounted along the tube's exterior. Compared to aviation and high-speed rail, a fully operational Hyperloop could deliver more passengers per kilowatt-hour than any transport system currently in existence. Meet the average American commuter. They spend 54 minutes every single day just getting to and from work. Across the United States alone, traffic congestion costs the economy over $87 billion every single year in lost productivity. Now imagine that same commuter living 200 miles from their office. With a functioning Hyperloop, that entire distance becomes a comfortable 20-minute ride. No security lines, no baggage delays, no 2-hour early arrivals, no gate changes. Just book a pod, board, and arrive at your destination. In 2020, Virgin Hyperloop conducted the world's first human passenger test at their DevLoop facility in Nevada. 2 passengers, 1 historic ride. Sarah Lukian and Josh Jeagle became the first humans to travel inside a Hyperloop pod. They reached 107 miles per hour in seconds. Lukian described the experience as incredibly smooth, far quieter than she expected, less like traveling and far more like floating effortlessly through space. India took notice. The Mumbai to Pune Hyperloop proposal promised to cut a 3-hour journey down to just 25 minutes. Ground was broken, environmental studies completed. For a brief moment, it looked like the future of transport was finally arriving on schedule. Then, in 2022, Virgin Hyperloop shut down its passenger division entirely, laying off half its workforce. The setback sent shockwaves through the industry. But the technology didn't die with it. Heart Hyperloop in Europe, Zeleros in Spain, and Swisspod in Switzerland all kept pushing forward regardless. The European Union committed over €700 million to Hyperloop research and infrastructure development. The project was far from over. The numbers behind Hyperloop aren't just impressive, they represent a fundamental reshaping of how the global economy moves people and goods. A 2021 report by KPMG estimated that a fully operational Hyperloop network could generate over $800 billion in economic value by 2040. Cities connected by Hyperloop would effectively merge into single economic zones. A worker in one city could realistically commute daily from another. On the environmental side, Hyperloop produces 0 direct emissions. Powered by renewable energy, its carbon footprint per passenger mile would be near 0. Studies suggest Hyperloop would consume up to 5 times less energy per passenger than commercial aviation on equivalent routes. In Europe, Heart Hyperloop completed full-scale tube testing in the Netherlands in 2023. Structural integrity confirmed across all key performance benchmarks. Their European Hyperloop Center became the first facility in the world to test full-scale Hyperloop infrastructure under real operating conditions. In the United States, Hyperloop One's successor company received federal backing to explore viable corridors between major metropolitan areas. Current projections suggest the first fully commercial Hyperloop route could be operational somewhere in the world before the end of this decade. And it isn't just passengers. Hyperloop cargo systems could slash intercity freight delivery times from days to under an hour. Perishable goods, medical supplies, emergency equipment, industries that depend on speed would be transformed overnight by Hyperloop freight infrastructure. The International Transport Forum estimates that building a global Hyperloop network would create over 4 million direct and indirect jobs worldwide. The data is no longer theoretical. The infrastructure is being built. The question now is not if, but where and when. The Hyperloop promises to reshape civilization, but every technology that promises that much also carries consequences that have to be examined carefully. The first and immediate challenge is cost. Building a single mile of Hyperloop infrastructure currently costs an estimated $40 to $100 million. A Los Angeles to San Francisco route alone would require an estimated $100 billion in upfront capital investment. That's before a single passenger boards. Then there's the terrain challenge. Hyperloop tubes must maintain near-perfect straightness across hundreds of miles. Mountains, fault lines, and urban density all complicate the route. In earthquake-prone regions like California, engineers must design tubes that can withstand seismic events without catastrophic pressure loss. Dot engineering has never been done before at scale. Safety protocols present another layer of complexity. If a pod experiences a systems failure inside a sealed vacuum tube, passenger evacuation becomes an entirely unique engineering problem. Engineers have proposed automatic pressure reintroduction systems and emergency braking protocols, but these systems have never been stress tested under real-world failure conditions at full operational speed. Then there's the human cost of construction. Thousands of miles of elevated tube infrastructure passing through residential areas, farmland, and protected ecosystems raises serious displacement concerns. Land acquisition alone could trigger decades of legal battles. The history of infrastructure projects in the United States shows that eminent domain disputes rarely resolve quickly. Critics also raise equity concerns. If Hyperloop tickets are priced like premium air travel, the technology risks becoming another tool that widens the gap between economic classes. Who gets to use the Hyperloop matters as much as whether it works. Public infrastructure built with public money should serve the public, not just those who can afford it. The airline industry is watching closely. Short-haul flights under 500 miles, which account for 30% of all aviation emissions, would become economically unviable if Hyperloop succeeds. Existing rail operators face an existential question. Billions already invested in high-speed rail infrastructure could become stranded assets if Hyperloop delivers on its promises. Geopolitically, Hyperloop has become a new arena of technological competition. The nation or region that deploys it first gains enormous strategic and economic advantages. China is already investing heavily in maglev technology that shares core principles with Hyperloop. The race for ground-level, ultra-high-speed transit is fully underway on a global scale. Proponents envision a world where geography no longer limits opportunity, where talent, commerce, and culture flow freely between cities that once felt impossibly far apart. But the ethics of transformational technology demand that we ask hard questions before the concrete is poured and the tubes are sealed, not after. The Hyperloop is not just a faster way to travel. It is a decision about what kind of future we are willing to build and for whom. We are standing at the edge of a transportation revolution that has no historical parallel. Not the railroad, not the automobile, not the jet engine. The physics work, the engineering is advancing, the investment is arriving. What remains is the collective decision to build it, and to build it right. Within a decade, a person somewhere in the world will board a commercial Hyperloop pod for the very first time. That moment is no longer science fiction. High-speed rail took a century to reach its limits. The Hyperloop is only just getting started, and the world it creates will look nothing like the one we live in now. The way humanity moves is about to change forever. Hit like, share this with someone, and subscribe to SynthCosmos. We cover the science reshaping our world as we know it every single week. We'll see you in the next one.